Welcome everyone, and I thought most of you was able to solve the problem, but for those who did not able to solve the problem, again I suggest you to don't get panic, because that will change nothing. So if you are not able to solve the problem, then it's okay, follow the video and try to implement the code on your board. And one more thing, from now onwards you will learn a new thing in every video that is different from your previous concept, and it will make you to think more and think properly, so that you can able to solve most of the problems. So let's start. And again, it's a typical one, so don't worry if you did not able to solve it. Now let's begin. So as I told you, we have used 10 LEDs. So there is a variable for each of these LEDs is required, that is int LED pin 4, 5, 6, 7, 8, 9, 10, 11 and 13. So for that we will use a bit type of variable this time, and an array instead of taking again and again. And in array we have 4, 5, 6, 7, 8, 9 and 10, 11, 12 and 13. I think they count to be 10, 3, 6, 9 and 10. So this is the declaration about pin numbers. And now we have a delay period, that is 65, that is required for the change in LEDs. And then we have another variable, that is direction, which is an inbuilt function also. And then we have a variable current LED, which we will use to denote the current LED on which the board is working. And let me initialize with 0. And then we have last variable, that is unsigned long change time. These are the variables that I have used based on my comfort. You can use any of variables that will make you feel better, but the direction variable is specific. You have to use direction and with a value of 1 at initialization. And now in void setup, again we will use a different concept to declare all these variables. So instead of writing again and again pin mode, we use a Fourier variable here. So what I want to say here is that you can use anything in programming anywhere. You have to just make this child, that is our Arduino ID here, to understand what it does have to do. So we have now x less than 10, and here I have parentheses. So I have written x less than 10 here because our beginning is from 0, not from 1. So remember this thing, 0 is also counted in programming language. And after that we have here pin mode LED pin, and now we use again array and value x at output. I think this is understandable to you and it makes a sense also. We have used a for loop, and for every of x value from beginning from 0 to 9 we have used the LED pin at output. Now there's a question that we have number from 4, 5, 6, 7, 8 and 13 up to, but we have used 0 to 10 here. Why shouldn't we have used 4 to 13? So the answer for this is you can also use 0 to 13, but here we are using values from, sorry, here you also use 4 to 13, but here we are using indexing. So indexing always begins from 0. It doesn't matter that whether you have 0, 1, 200 lakh here, but the index for that thing is 0. Here we have 1, and similar to this we have different indexes at different positions which are fixed. So the value changes but the index remains same. So this is about the initialization of LEDs. Now we have our change time that we have to use, and it's in millis. Now you will understand why I have used this. And now let me move to void loop. And again, I have told you, you will learn different new things in every of the video. So we have used nearly most of the difficult concepts here, that is array concept and for loop and for loop in void setup. And now there's a one concept left, functions. So now let me try to build this chase effect by function, and we will build another one without function. So again, first of all, we have an if condition, that if the millis minus change time. That's why we have initializes change time in millis, because we have to subtract it from millis. And if this thing is greater than 65, that is our LED delay time. Here we have D capital delay. And what will happen then? Here we use a function change LED. Let me capitalize it. So what will happen in change LED is defined after the void loop, because we defined our functions after void loop, because void loop is also a function here. And now in we have to change time and millis, as we have to make this value specific. So this is about the void loop, and now you are assuming this is smaller than even a blink LED, but here we have used a change LED function, and now we will define this function. You can also directly write the code here in the void loop, but as I told you that we are using functions now, so we will define it in a function. So this is the method to define a function. We have change LED and then these parentheses, which means that we are using some parameters in this, and then we have curly braces. And I have told you that we have to use a void in case of functions to declare the function, and if the function has integer output, then we use int. So what will happen in this function? Then we use a for loop with value x from 0 to x less than 10, and with an increment of plus plus, that is +1, and we will make every of LED pin, and here we have the indexing at low. So I think now the program is getting interested, because we are using again and again arrays, loops and functions. And now you think that how it will make a chase effect, because it's a common function to make the LED glow, because it's not completed yet. So what does after this came is that here we use again digital write, and we have LED pin with analog values, that is current LED. The function, sorry, the variable we have used here, the current LED, and make that high. What I'm saying is we require current LED. So the variable current LED have initialized value 0, and we have used this variable to interface with the direction. But I want to say that it's actually a direction concept, that we are from 0 to 1 coming here, and then from 1 to 0 in forward and backward directions. And what I'm saying also here is the usage of analog values, that I forgot to mention after writing current LED, that you can also use different values from 0 to 225, that is brightness is value, so that the chase effect will be a little beautiful. It will start from 0 brightness and goes up to higher, and then from higher to lower, and then from higher to lower here in different ways. So that was a different thing also you can use here, but we are using simple one. So we have current LED here, and current LED is equal to positive of direction. So the value of current LED is changing by positive of direction. It means that it's increasing by the value of direction factor. So now I think you understand what I have done here is that I have written digital write to LED pins with the current LED, and the current LED is the increment in value by the factor of direction. And there are now two cases here. If either the direction is beginning from 0 or beginning from 1, so if the current LED, as the current LED is just denoting the factor, the LED at which we are on that point, like the direction is initialized at 1 value, so it's from 1 and then it will increase up to last, that is 9th, and 9 plus 1 is equal to 10, so we use maximum factor of 9. So if the current LED equal to 9, then what will happen here, we have to just change the direction to -1, and if the current LED, capital D here, equal to 0, what it means that whether it's on this LED or this LED, then it will define the direction of LED, that if it has to go from here right side, from 0 to right side, or 0 to left side. But on left side we have nothing, so it will declare that if it's equal to 0, then the direction is positive, and if it equal to 9 here, then the direction is negative. I think you understand. It's a little complex code, that's why you need to have focus on this. And then we have the direction +1. So this is the code for this LED chase effect. I think I should have to again tell you that what I have done here. So I have declared different variables. First one is the LED pin, that is the value of different LED pins. Then I have taken a different variable, that is LED delay 65 millisecond. And what actually this variable is doing, it is the time of is this LED glow or high, whether is LED is glowing or at not glowing. But as we require the chase effect, so this one denotes that the time for which the LED is glowing. Then we have the direction, that is the positive one or negative direction. And then we have taken a current LED which is at 0 first, which is makes the flow of path, which depends on the direction. Then we have a time unsigned long variable, and after that we have declared every value, initialize every value in void setup. And then this is what I have told you already, and it's easy part. And in this we have generally written every value at low, and then we have written every value at high depending on the direction. So this is our code. Let me compile it. You can save the code. So here we go, nearly it's compiled. Here pin mode, sorry, I have written capital O here instead of small o, and I did not have even noticed the color changing this time. So now we check the code again. Expected declaration. Again, sorry for this issue. I have written a token here, but I forget that I have already mentioned this one in last. So sorry for this common mistakes that I forget while explaining you the code. So now the code is correct, I thought. Here it is done compile. So here we are on the board, and now let me build the circuit. So you have to take care of some little things in this circuit. That first is that don't break the circuit after the problem, because in night hider we also require this one. And for building the circuit, just take one point, like there are 10 LEDs that are going to be used in this code. So we take the pin number 20 first, and then connect a wire on pin number 20 so that it will be positive terminal of that LED, and then on 19 a resistor and connect its second terminal this side so that it will be grounded, because we do not have 10 grounds. Then again a wire, otherwise it will be a little complex to build this circuit because it's more difficult than our other small circuits. Here we have the another LED, sorry, another wire, and then again resistor, but it's connected upward. Now it's okay. Then we have again a wire. Similar in this way, you have to make connections for all the resistors and wires. You can skip the video until I'm connecting all these. By the way, it's just 5 more resistors. Building this circuit in this way is more easy than connecting every LED one by one. Here we go, just 2 more resistors after this, and this one get paralyzed. And here we have another wire, and then the last resistor. Sorry, one more after this. So as these all are short circuited in horizontal lane, we just require a single wire there to ground every of these. So here we go with the connection, so it will look like something this. Now let me make a ground common. So here we have the ground, and we have connected it to ground of Arduino. Let me switch off the Arduino first. And now from pin number 4 to 13, now let me connect every of these. So here we have this one, and then this. Maybe I have mismatched the circuit. Now orange. Always use colorful wires in this circuit, because sometimes the circuit will get mismatch. And here we go. Now only LEDs are required. So having the negative part on this side and positive this side, connect all these LED beginning from last one. So here we have the LED, and similar in this way. just focus on the center part. The larger one is negative, and then go on. Just 4 more. Now here we have this one, also get paralyzed. So just do them lightly so your LEDs will be safe. And here we have 2 more. Now the last one. So here we go with the connections. So this one looks like something like this, a complex circuit, but when you power up the Arduino it will look much prettier. So here we go. So as you can see here, this little snake is going first from left to right and then right to left. So this is the chasing effect. Now don't break the circuit, it is required in Night Rider, and in Night Rider, like this snake, there will be a snake of 3 LEDs at a time. So wait for that project and enjoy that one until that. So very interesting here. So see you in the next problem, and thanks for watching.